Section 12.3, the quadratic formula. Very important section because it's an alternative way to solve for x. In 12.2, the way we isolated the variable was by taking the square root. And in order to make it nice to take the square root, we created binomial squares by completing the square. Well, as we saw, sometimes when a is not 1 or b is an odd number, it actually makes for a somewhat laborious, time-consuming process. So what we can do is we can use what we call the quadratic formula. The quadratic formula is it says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now those variables a, b, and c come from the trinomial. Notice first of all that it's set equal to 0. We have to have ax squared plus bx plus c equals 0. So my a value is going to be the coefficient of x squared. My b value is going to be the coefficient of x. And then my c value is going to be my constant. And I didn't do my a value down there. So in this example, if we look at problem number 1, a equals 1, b equals -3, and c equals -10. Now we take those values and we're going to substitute them into the equation. Wherever we see those variables, we're going to plug in those numbers. So using that, we get the opposite of b, the opposite of -3, plus or minus the square root of b squared, -3 squared, minus 4a times 1, times c, which is -10, all over 2a, 2 times 1. And now we're going to simplify. So if we simplify, the opposite of -3 is +3 plus or minus -3 squared is 9, minus 4 times 1 times -10 gives us +40. We're going to simplify inside of the radical to get the square root of 49. That's a perfect square. So we get 3 plus or minus 7 divided by 2. So we have to separate those two. So we're going to separate them to the plus side of 7 and the negative side of 7. So we get 3 plus 7 over 2 and 3 minus 7 over 2. 10 over 2 reduces to 5. 3 minus 7 reduces to -4 over 2. So we get -2. So my solutions are -2, 5. I think that those are nothing. The next problem, we get 2y squared minus 6y minus 8 equals 0. We're always going to use this formula. X equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. You must memorize that. That will not be provided on any assessment or test. We see that a equals 2, b equals -6, c equals -8. So we plug those values in. We get the opposite of -6 plus or minus the square root of 6 squared, -6 squared, minus 4 times 2 times -8, all over 2 times 2. Opposite of -6 is +6. Quantity of -6 squared is 36. -4 times 2 times -8 is 64. We again see that we get a nice perfect square in the radical. So that produces 6 plus or minus 10 over 4. We separate them into positive and negatives. 16 over 4 gives us 4. -4 over 4 gives us -1. My solution is -1, 4. Let's look at this one where we see that it's not set equal to 0. And that's probably the biggest place that I find that students make their mistake is they think C is 13 because they just look for the constant. But we have to remember that you must always set the equation equal to 0. You must set it equal to 0. So we have subtracting 13 from both sides, and we get j squared minus 6j minus 13 equals 0. Now we can pull out A, B, and C. We do so. We have the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times negative 13. That was weird. All over 2 times 1. 36 plus 52 gives me 88. Now that will not be a perfect square, so we will end up with an irrational number. Square root of 88. I don't know why I did that. That was interesting. Should have broken that into 4 times 22. Square root of 4 becomes 2. And now we cannot leave this as an answer. This 2 cannot cancel with the 22 because the 2 in the denominator is outside, the 22 is on the inside, and we can't just cancel with these two. If you're gonna simplify, it has to be all 3 outside numbers. So because 6, 2, and 2 do have a common factor of 2, we can reduce that by 2, and we end up with 3 plus or minus rad 22 will be my final answer. That can be a little complicated, so we have to be careful of that mistake. Let's show a couple examples. So if we have 3 plus or minus 5 rad 10 over let's do over 15. That would be a nice tricky one. People would think that you could simplify that. You cannot. That is your final answer. Oh, but you say, hey, 3 and 15 can be simplified, and 5 and 15 can be simplified. But they can't be simplified by the same number. This can be reduced by 5, or excuse me, by 3, but this cannot be simplified by 3. So what we have to really understand is that all 3 must have a common factor. 3, 5, and 15 do not have a common factor. Another example would be something like this. 2 plus or minus rad 10 over 6. That cannot be simplified because there's an invisible 1. And there's no number that goes into 1, 2, and 6, or at least the greatest number is 1. So that is simplified. That is another tricky problem. This is simplified. That is simplified. Okay, so be careful of that. Those are 2 really tricky problems that students oftentimes make mistakes. Here we have our A is negative 4. Sorry, we want. I don't know why I did that, but apparently, no. That's interesting. Why did I do that? A is negative 4. Oh, I guess I never fixed it. B, yes, that's wrong. A is not negative 1. Sorry. I copied and pasted and didn't see. A equals negative 4, B equals 2, and C equals 3. So we plug in opposite of B, which is negative 2, plus or minus square root of 2 squared minus 4 times negative 1 times 3. All over 2 times negative 1, negative 2 plus or minus. We get square root of 16. We're going to simplify that. I didn't simplify. I don't know why I'm duplicating in certain places. Square root of 16 is 4. We're going to separate them into 2 different problems. Negative 2 plus 4, negative 2 minus 4. We get 2 over negative 2, which is negative 1. We get negative 6 over negative 2, which is positive 3. And my solution is negative 1, 3. Negative 1, 3. Negative 1, 3. Written like that.